Hi there. Today I want to show you how you can replicate my parent constraint with a bunch of DG nodes inside my node editor. So here you can see a scene with three different objects. One is a target, another one is its parent, and the constraint object. This object would move the target for me. And first of all, let's see how my apparent constraint, the standard my apparent constraint node works. First I want to create it and show which options it has. So let's select my constraint object, my target, and create a constraint. So let's see the options. Here we can see that it has the maintain offset set on, and if I create my parent constraint, you can see that my target object has connection of its parent inverse matrix with a constraint node, as well as a bunch of different other connections like rotation order, rotation pivot, and rotate pivot translate. But at the moment we can ignore it because of my rotate pivot and rotate pivot translates are zero vectors and I don't move my pivot. So let's delete my parent constraint and try to replicate the maintain offset mechanics. For this we can use multiply matrix node, but I have my own multiply matrix node which I wrote instead of standard Maya multiply matrix node. So let's create a multiply matrix node. You can use a standard one, but the drawback of standard multiply matrix node is that when you connect some attribute, some matrix attribute into the input of the multiply matrix node, and then disconnect it, Maya would delete it and it doesn't keep it. So first I want to find the difference transformation between my target and my constraint object. And for this I need to use my world matrix of my target as a operand A and the world inverse as operand B, and that would give me the difference between these two objects in transformation. And this maintain offset matrix should be a constant one, so that's why I have to delete the connections, just disconnect my matrices. So here we keep it aside, and I would need another multiply matrix node where I can plug in my offset. So I apply my offset to my constraint object world matrix, and that should give me this transformation of my target. So if I create some join and plug this result matrix into my joint offset parent matrix, we would see that my joint is aligned to my target exactly. So now I can delete this joint, and we have to consider the fact that my target is parented to some other object like this parent, and to compensate for that, I would need to create another multiply matrix and multiply my result with a parent inverse. So that's exactly the same parent inverse that we have in standard my-apparent constraint. And now we can decompose our result here and plug my rotation, translation, and scale into my target. So now that would replicate the parent constraint almost exactly, but with only difference that the parent constraint, the standard my-apparent constraint, doesn't have the scale output. So to compensate for that, we can just decompose the constraint object world matrix and recompose it back, but without the scale. So now we can see that we don't have the scale, but the rest of the constraint mechanics is the same. And my parent object doesn't affect the target anymore. We can improve our setup a little bit, just combining everything into a single matrix product node. Let's create matrix product node and start combining everything together. So first we would need to plug our constant matrices first. Let's disconnect them. Then we plug our world matrix as a third input, and let's plug without the scale. And the last one would be the world inverse of my parent object. And here we can plug it into the decompose instead of our multiply matrix nodes. So let's disconnect all this stuff, and now we can delete these 3 multiply matrix nodes. Come on. Delete. So here you go, that the parent constraint with DG nodes inside my node editor. So the parent constraint in a nutshell.